My name is Sunesh Menman. Welcome to Amity College Science Daily. Today I have a very special report for you. Today I am going to dispel a misconception of basic science, and the topic is based off the branch of physics.
If you were sitting in a bus moving at a constant speed and you throw a ball upwards, where would it land? Why don't we ask some students and make a survey?
If you throw a ball upwards and the bus is moving forwards, the ball is going to land backwards. When the ball is thrown up, it will land with you.
It will land behind you.
It lands in your lap. It will land in front.
So if you think about it, when you're moving and you throw a ball like a PE, then it's the same thing. It's going to land where you want it. So if you're moving and you throw the ball, it's going to land in front of you.
It will land back in my hand. It will land in front of me.
It's going to land behind me.
The ball will land right back into my hand. It will land behind me.
The ball will land behind me.
It will land behind because the bus is traveling forward. Can I get my thing now?
According to our survey, 3 people suggested that the ball will land in front of you, 5 people suggested that the ball will land back to you, and 7 people suggested that the ball will land behind you. But out of all of these, which is the correct answer? It will land right back into the hands of the person who threw it. But why? We can explain the answer to this question using Newton's laws 1 and 2, concept of relative speed, horizontal and vertical velocity, and projectile motion. Now time to explain the answer. The concept of relative speed. If the bus is moving at 30 km per hour, you are moving at 30 km per hour. Since the bus and you are moving at the same speed, so is the ball. All 3 are moving forward at the same speed. As you are travelling inside the bus, your speed and the bus's speed is identical. Since you are not moving relative to the bus, whatever you throw vertically upwards will land right back to where it was. To you and the other passengers on the bus, it seems as if the ball is just going up and back down with no parabolic path, but to someone observing from the outside, you will see the ball arc up and down as you move. Horizontal and vertical velocity. Velocity is the rate of motion in a specific direction. Horizontal velocity in this case is the speed, velocity of the bus on the ground, and the vertical velocity is up-down, vertical speed, velocity, in this case the ball, which is being thrown up. Because the ball, you and the bus are at 0 relative velocity in horizontal direction, in your reference plane the only velocity that governs the path of the ball is the y-axis velocity. For anyone inside the bus, throwing the ball up will be the same as throwing the ball up in a non-moving bus. But for anyone who is standing still on the ground, the path of the ball will be a parabolic path. Projectile motion. According to Galileo, projectile motion consisted of both horizontal and vertical components. These components were independent of each other and orthogonal to each other. Vertical acceleration was the same for all falling objects if air resistance wasn't taken into consideration. Horizontal velocity stays the same, but vertical velocity doesn't. Galileo's relativity. Galilean relativity states that the laws of motion are the same in all inertial frames. Galilean relativity today usually refers to this principle as applied to Newtonian mechanics, that is, Newton's laws hold in all inertial frames. There exists an absolute space in which Newton's laws are true. An inertial frame is a reference frame in relative uniform motion to absolute space. All inertial frames share a universal time.
Okay, so we're going to do a demonstration now. We couldn't really get a bus, but we're going to use a car. It's the same concept.
Okay, so the car was going at a constant speed, and as we can see, the ball just lands right back into my hands. As I throw the ball up, there is a parabolic path and the ball moves at a bit of an arc. This is because we are observing from the outside. Now I recorded from inside the car. As you can see, the ball just lands straight back into my hands. It just moves up and back down. And this is only because we are observing from inside the car. Thank you for watching this episode of Science Daily. Stay tuned for next time.